Good morning.
Very good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning. Good morning. Let's start. The problem is what we solved so far. The curve was expressed in terms of polar coordinates. They are called polar curves, and we found radius of curvature in case of polar curves. Now we shall take up a few Cartesian curves. Equation of radius of curvature in Cartesian curve. And the equation of a radius of curvature in case of Cartesian curves is given by 1 plus y1 square whole power 3 by 2 divided by y2, and this rho stands for the radius of curvature. And y1 is first order derivative, y1 or dy by dx. In either ways you can write that, or y dash. You can use any of these three notations, y1 dy by dx or y dash. 1 plus y1 square whole power 3 by 2 divided by y2. y2 is a second order derivative. You can use this notation y2, or you can use this d square y divided by dx square, second order derivative, or y double dash. You can use any one of these three notations here. Rho radius of curvature is 1 plus y1 square whole power 3 by 2 divided by y2. Now let's take up a problem. You will come to know what kind of problems these radius of curvature problems are. Show that the radius of curvature for the curve y is equal to a log secant x by a is a secant x by a. Clearly this is a Cartesian curve because expressed in terms of x and y. Show that the radius of curvature of this curve is a into secant x by a, where a is a parameter. For a different a you get a different curve. Let y is equal to a log secant x by a. What is requirement here? To apply this formula, y1 is required, y2 is required. First we shall find first order derivative and second order derivative. Let's differentiate this equation with respect to x. Derivative of y is dy by dx or y1. This is equal to, here a is a constant, keep this constant as this. Derivative of log secant x by a is 1 over secant x by a. Derivative of log secant x by a is 1 over secant x by a. Derivative of secant x by a is secant x by a into tan x by a. Derivative of secant theta is secant theta into tan theta. Therefore, derivative of secant x by a into tan x by a. Now, derivative of x by a is 1 by a. Am I audible?
Yes, sir.
Okay. Derivative of log secant x by a is 1 over secant x by a, and that of secant x by a is secant x by a into tan x by a, and derivative of x by a is 1 by a. Now cancel this a with this a, secant x by a with this secant x by a, we get tan x by a. y1 is equal to tan x by a. This is first derivative. In order to obtain the second derivative, differentiate the expression with respect to x by a. Differentiate with respect to x. Derivative of y1 is y2 or d square y by dx square. Derivative of y1 is y2. Derivative of tan theta is secant square theta. Therefore, derivative of tan x by a is secant square x by a. Into derivative of this x by a is 1 by a. 1 by a is constant. Derivative of x is 1. Derivative of x by a is 1 by a. These are the two required derivatives, y1 and y2. Now, radius of curvature rho is equal to 1 plus y1 square. What is y1 here? y1 is tan x by a. Therefore, y1 square is tan square x by a. Whole power 3 by 2. Whole power 3 by 2. This divided by y2, and y2 is secant square x by a into 1 by a. Rest is very simple. This is equal to, that means rho. You transform this a to numerator. A into, now this takes 1 plus tan square theta. 1 plus tan square theta is secant square theta. Therefore, 1 plus tan square x by a is secant square x by secant square x by a whole power 3 by 2. This divided by secant square x by a. Secant square x by a. Therefore, rho is equal to a into secant square x by a whole power 3 by 2. You just cancel this 2 with this 2. 2 into 3 by 2 is 3. Therefore, secant cube x by a. Secant cube x by a. This divided by secant square x by a. This is equal to a into this a as it is. Secant cube theta divided by secant square theta is secant theta. That is secant x by a. This is what we require. Radius of curvature is a into secant x by a. A into secant x by a. Is this clear?
Yes, sir.
Okay, please make
Yes,
it
sir.
yes. You note down this problem. Is this over?
Yes, sir.
Next one. This is a question paper problem. Find the radius of curvature for the curve y is equal to ax square plus bx plus c at x is equal to 1 by 2a into square root of a square minus 1 minus b. Find the radius of curvature for the curve y is equal to ax square plus bx plus c. Clearly, this is a Cartesian curve expressed in terms of x and y. At the point where x is equal to 1 divided by 2a into square root of a square minus 1 minus b. Let y is equal to ax square plus bx plus c. First, we have to find first order derivative and then second order derivative. Differentiate with respect to x. Derivative of y is dy by dx or y1. The derivative of ax square is 2ax. A is constant, derivative of x square is 2x. Plus derivative of bx is b. Plus c is a constant, its derivative must be 0. And the derivative of y2. Differentiate this expression throughout with respect to x. Derivative of y1 is y2. Derivative of 2ax is 2a. Plus b is a constant, its derivative must be 0. And these two derivatives are required at a point where x is equal to 1 by 2a into square root of a square minus 1 minus b. Substitute here. Therefore, y1 is equal to 2a into x and x is 1 over 2a square root of a square minus 1 minus b plus b as is. Cancel this 2a with this 2a. Square root of a square minus 1 minus b plus b. Cancel this minus b with this plus b. You get square root of a square minus 1. This is y1. And y2 is constant. There is no x here. You keep it as it is. y2 is equal to 2a. Now substitute here. Rho is equal to 1 plus y1 square. 1 plus y1 square. y1 is a square root of a square minus 1. Therefore, y1 square is a square minus 1 whole power 3 by 2 divided by y2. What is y2? y2 is 2a. Cancel this plus 1 with this minus 1. This is equal to a square whole power 3 by 2. This 2 will get cancelled with this 2. You just get a cube. A cube divided by 2a. Or this can be written as a square divided by 2. A square divided by 2. This is always a positive quantity. A square divided by 2. Make a note of this. Next, find the radius of curvature for the curve y square is equal to x cube plus 8 at minus 2 comma 0. Find the radius of curvature for the curve y square is equal to x cube plus 8 at a point where x is equal to minus 2 and y is equal to 0. Let y square is equal to x cube plus 8. We shall find the derivatives. Differentiate with respect to x. Derivative of y square with respect to x is 2y, correct? Derivative of y square is 2y into derivative of y with respect to x is dy by dx are just y1. Therefore, 2y into y1. 2y into y1. This is equal to derivative of x cube is 3x square plus 8 is a constant. Its derivative must be 0. Derivative of y square is 2y and derivative of y with respect to x is dy by dx. It is denoted by y1. 2y into y1 is equal to derivative of x cube is 3x square and 8 is a constant. Its derivative must be 0. Therefore, y1 is equal to 3x square divided by 2y. Here, we keep y1 here, 3x square divided by 2y. This is first order derivative, and these derivatives are required at a point where x is equal to minus 2 and y is equal to 0. Put x is equal to minus 2 and y is equal to 0. When y is equal to 0, this denominator will be 0 and numerator will be a finite quantity. A finite quantity divided by 0 is not defined, it is called infinity. Therefore, y1 becomes infinity. We cannot find y1 and y2. In such cases, we take the reciprocals. y1 means dy by dx. Its reciprocal is dx by dy, or you can write it as x1. In either ways, you can write that dx by dy or x1. This is derivative with respect to y. Now take the reciprocal. Reciprocal of this dy by dx is dx by dy. It is denoted by x1. We just interchange numerator into denominator and denominator into numerator. That is 2y divided by 3x square. At minus 2 comma 0, this numerator will be 0 because y is equal to 0. This is x and this is y. Numerator is equal to 0 and denominator is a finite quantity. 0 divided by any finite quantity is 0. x1 is equal to 0. Now we have to find the second derivative. This is dx by dy, derivative with respect to y, not with respect to x. Therefore, we differentiate with respect to y, not with respect to x. We keep this in mind. This is derivative with respect to x and this is derivative with respect to y. Because we converted this dy by dx into dx by dy. Therefore, we differentiate with respect to y. Roles of x and y are interchanged. Derivative of x1 is denoted by x2. Here 2 by 3 is a constant, keep it as it is. Differentiate y by x square with respect to y using quotient rule. What is quotient rule? Denominator into, that is x square into derivative of y with respect to y is 1. minus numerator y into derivative of denominator x square is 2x. And the derivative of x with respect to y is x1. Derivative of x with respect to y is x1, correct? Into x1 whole divided by denominator square, that is x square whole square, x power 4. This is quotient rule. 2 by 3 is constant. We keep that constant as it is. 2 by 3. Denominator into, that is x square into derivative of numerator. Derivative of y with respect to y is 1. Minus numerator y into derivative of denominator x square is 2x. Into derivative of this x is x1. Derivative of x with respect to y is dx by dy, that is x1. Whole divided by denominator square. X square whole square is x power 4. That's what I have written here. And this derivative is required at minus 2 comma 0. Minus 2 comma 0. When x is equal to minus 2 and y is equal to 0, x1 is equal to 0. Therefore, this product is equal to 0 because x1 is equal to 0. 0 into anything is 0. Therefore, this term will be 0. So what you get here is 2 by 3 into this 2 by 3 into x square. X is minus 2 whole square is 4. Divided by minus 2 whole power 4 is 16. On simplification, you get 1 by 6. X1 is equal to 0 and x2 is equal to 1 by 6. Now we can easily find the radius of curvature. Actually, radius of curvature is given by rho is equal to 1 plus y1 square whole power 3 by 2 divided by y2. Now the roles of x and y are interchangeable. Therefore, equivalently we write, how to write that? 1 plus x1 square whole power 3 by 2 divided by x2. Now we have x1 and x2 substitute. Rho is equal to 1 plus x1 square and x1 is equal to 0. Therefore, 0 square is 0 whole power 3 by 2. 1 power 3 by 2 is 1 divided by x2. x2 is 1 by 6. 1 over 1 by 6 is 6. Radius of curvature is 6. For your doubts, you can unmute and ask. You make a note of this problem. If it's over, we'll move on to next problem. Is this over?
Yes, sir.
Okay. Find the radius of curvature for the curve y is equal to 4 sin x minus sin 2x at pi by 2 comma 4. This is another question paper problem. It appeared 2 times in the past examination. Find the radius of curvature for the curve y is equal to 4 sin x minus sin 2x at pi by 2 comma 4. Let y is equal to 4 sin x minus sin 2x. And we know that rho is given by 1 plus y1 square whole power 3 by 2 divided by y2. Therefore, we shall find y1 and y2. Differentiate with respect to x. Differentiate with respect to x. Derivative of y is dy by dx or y1. 4 is constant, keep it as it is, this 4. And derivative of sin x is cos x. Minus derivative of sin 2x is cos 2x. Into derivative of 2x with respect to x is 2. 4 cos x minus 2 cos 2x. And this derivative is required at pi by 2 comma 4. X is equal to pi by 2 and y is equal to 4. Substitute. Put x is equal to pi by 2 and y is equal to 4. At pi by 2 comma 4, 4 into cos pi by 2. What is cos pi by 2? 4 into cos pi by 2. What is cos pi by 2?
0.
0, right. Minus 2 into cos 2 pi by 2. Cos 2 pi by 2. This is equal to 4 into 0 is 0, minus 2 into, cancel this 2 with this 2, cos pi. Cos pi is minus 1. Minus 1 into minus 2 is plus 2. Therefore, this is equal to 2. Y1 is equal to 2. Now we find Y2. To find Y2, differentiate Y1 with respect to X. Differentiate Y1 with respect to X. Derivative of Y1 is Y2. 4 is constant, keep it as it is, and derivative of cos x is minus sin x. Minus 2 into derivative of cos 2x is minus 2 sin 2x. Minus into minus plus 2 sin 2x into derivative of 2x is 2, 2 into 2 is 4. 4 into derivative of cos x is minus sin x. Minus 2 into derivative of cos 2x is minus sin 2x. Into derivative of 2x is 2. That's what I have written here. Minus 4 sin x. Minus into minus plus 2 into 2 is 4 sin 2x. At pi by 2 comma 4, put x is equal to pi by 2 and y is equal to 4. Then y2 is equal to minus 4 into sin pi by 2. What is sin pi by 2? What is
1.
sin pi by 2? Sin 90 degrees, sin pi by 2 radians. Table ಕೊಟ್ಟಿದ್ದೆ ನಿಮಗೆ 1. You must memorize all these values. Sin pi by 2 is equal to 1 plus 4 into sin 2 pi by 2. Sin 2 pi by 2. This 2 will get cancelled with this 2. You get sin pi. What is sin pi?
0.
0. 0 into anything is 0. Therefore, this is equal to minus 4. Rest is very simple. Write the formula, substitute. Rho is equal to 1 plus y1 square. y1 is 2. Therefore, 1 plus 2 square is 4. Whole power 3 by 2. This divided by y2. And y2 is minus 4. Rho is always a positive quantity. Therefore, you can neglect this negative sign and write the magnitude only. That is 1 plus 4 whole power 3 by 2 divided by 4. 1 plus 4 is 5. Correct? 1 plus 4 is 5. 5 cube is 125. 1 plus 4 is 5. 5 cube is 125. 125 whole power 1 by 2 is square root of 125 divided by 4. Therefore, rho is equal to square root of 125. 125 can be written as 25 into 5 divided by 4. This is equal to square root of 25 is 5 into square root of 5 as is divided by 4. This is the radius of curvature. 5 root 5 divided by 4. ನಿಮ್ಗೆ ಗೊತ್ತಾಗದೇ ಇದ್ರೆ ಇಲ್ಲೇ ನಿಲ್ಲಿಸಬಹುದು, ನೋ ಪ್ರಾಬ್ಲಮ್. ಗೊತ್ತಾದ್ರೆ ಎಷ್ಟು ಸಾಧ್ಯವೋ ಅಷ್ಟು ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡಿ. So make a note of this.
excuse me, sir.
Ah, ಹೇಳಿ.
Sir, y2 is -4, na, sir?
y2 is -4, but rho is always positive. Therefore, you can neglect this negative sign.
Okay, sir.
Otherwise, you will get a -5√5 divided by 4. Then you remove that negative sign. Is that clear?
Yes, sir.
Okay. Next one. Find the radius of curve. This is very, very important problem. Find the radius of curvature for the curve y square is equal to 4e square into 2a minus x whole divided by x, where the curve meets x-axis. How do you approach this? Where the curve meets x-axis, the point is not specified. First, we find the point where rho is to be determined, right? The curve meets x-axis. X-axis will be like this. This is y-axis. The curve meets x-axis means at a point on x-axis, y is always 0. Correct? On x-axis, y is always 0. Therefore, y coordinate must be 0. Since y is equal to 0, this expression y square is equal to 4a square into 2a minus x. This divided by x. Since y is equal to 0, y square is 0. 0 into anything is 0. Therefore, 4a square into 2a minus x is equal to 0. 4a square into 2a minus x is equal to 0. Since the product of these two terms is equal to 0, that is 4a square into 2a minus x. The product of these two is equal to 0. At least one of the two is equal to 0. That is either 4a square is equal to 0 or 2a minus x is equal to 0. But you cannot equate 4a square to 0 because 4 is positive greater than 0. A square is also positive greater than 0. A is always a positive quantity here. Therefore, a square is also a positive quantity. The product 4a square is greater than 0. Therefore, this cannot be 0. Therefore, 2a minus x is equal to 0. 2a minus x is equal to 0 implies x is equal to 2a. Therefore, x comma y, that is 2a comma 0. X is equal to 2a and y is equal to 0. X comma y, this is the point at which rho is to be determined. Therefore, 2a comma 0 is the point on the curve at which this rho is to be determined. Is that clear? Now, y square is equal to 4a square into 2a minus x divided by x. We shall rewrite this. 4a square into 2a is 8a cube divided by x. 8a cube divided by x. 4a square into minus x divided by x, that is minus a square. The equation is rewritten. Now differentiate with respect to x. Differentiate with respect to x. Derivative of y square is 2y into derivative of y is y1. 2y into y1. This is equal to, here 8a cube is a constant. Keep it as this, 8a cube. Derivative of 1 by x is minus 1 by x square. Therefore, minus 8a cube divided by x square. This minus 4a square is a constant. Its derivative must be 0. And this implies y1 is equal to minus 8a cube divided by 2y into x square. Minus 8a cube divided by 2y into x square. This 8 is exactly divisible by 2. How many times? 4 times. Therefore, minus 4a cube divided by x square into y. And this is required at 2a comma 0. That means x is equal to 2a and y is equal to 0. When y is equal to 0, this denominator will be 0. And numerator is a finite quantity. Any finite quantity divided by 0 is not defined. It is called infinity. Therefore, y1 will not exist. In such cases, we take the reciprocal. y1 means dy by dx. Reciprocal of this dy by dx is dx by dy. Or we call it as x1. Therefore, x1 is equal to minus into this minus into Interchange numerator into denominator and denominator into numerator. X square y divided by 4a cube. At 2a comma 0, y is equal to 0. Since this y is equal to 0, now numerator will be 0. 0 divided by any finite quantity is 0. X1 is equal to 0. Now we find x2. To find x2, we differentiate this. X1 means dx by dy. This is the derivative with respect to y. Therefore, we have to differentiate with respect to y here, not with respect to x. This is with respect to x, but here it is with respect to y. Derivative of x1, x2. Here minus 4a cube is a constant. Minus 1 divided by 4a cube is a constant. Keep it as it is. You just differentiate x square into y using product rule. X square into derivative of y with respect to y is 1. Correct? Derivative of y with respect to y is 1. Plus y into derivative of x square is 2x. Into derivative of x with respect to y is x1. That is the differentiation. Derivative of this x1 is denoted by x2. Here minus 1 divided by 4a cube is a constant. Keep this constant as it is. You just differentiate x square into y. X square into derivative of y with respect to y is 1. Plus y into derivative of x square with respect to y is 2x. Into derivative of x is x1. And this derivative is required at 2a comma 0. Both the derivatives are required at 2a comma 0. At 2a comma 0, x1 is 0. Therefore, x1 is 0, 0 into anything is 0. Therefore, this entire term is 0. This is equal to minus 1 divided by 4a cube into x square. X is 2a, right? X is 2a. Therefore, x square is 4a square. You cancel this 4 with this 4. You get minus 1 divided by a cube into a square is minus 1 divided by a. Minus 1 divided by a. The rest is very simple. What will be the formula now? X and y are interchanged. Therefore, rho is given by 1 plus x1 square whole power 3 by 2 divided by x2. This is equal to 1 plus x1 square. X1 is 0. Therefore, this is 1 plus 0, 1. 1 power 3 by 2 is 1 divided by x2. X2 is minus 1 by a, but rho is always positive. Therefore, I leave this negative sign and write 1 by a only. 1 over 1 by a is a. This is the radius of curvature. Is this clear?
Sir, can you repeat that part where you found 2a comma 0?
Pardon? I didn't hear you. What is your doubt?
Can you please repeat that part? Sir, can you please repeat that part where you found the points 2a comma 0?
Okay, 2a comma 0.
Yes, sir.
Okay. Rho is required at a point where the curve meets x-axis. The curve meets x-axis means x-axis is horizontal line. The curve will be something like this. But meets x-axis means this point of meeting is on x-axis. On x-axis, y is always 0, correct? On x-axis, y is always 0. If y is equal to 0 here, you get 0 is equal to 4a square into 2a minus x divided by x. So just simplify. 0 into x is 0. This is equal to 4a square into 2a minus x. And the product of these two means, or at least the product of these two terms is equal to 0 means at least one of the two terms is equal to 0. That is either 4a square is equal to 0 or 2a minus x is equal to 0. But you cannot equate 4a square to 0 because 4 is positive, a square is also positive. 4 is greater than 0, a square is also greater than 0. Therefore, this product is greater than 0. You cannot make it 0. Therefore, 2a minus x must be 0. That means x is equal to 2a. Therefore, x comma y is 2a, x is 2a and y is 0. This is the point of intersection at which we found rho. Clear?
Okay, sir. Thank you.
After this session, you go through this problem again. If you find difficulties, I'll repeat the problem again tomorrow because this is a very, very important problem. If it's over, I'll move on to the next problem. We have less than 1 minute. You just note down this problem and try to solve this by yourselves at your home. Anyway, I'll solve this tomorrow. Find the radius of curvature of the curve x square y is equal to a into x square plus y square at the point minus 2a comma 2a. You try to solve this problem by yourselves at your home. X square y is equal to a into x square plus y square at minus 2a comma 2a. Put your attendance in the chat box.